All right, now that you know a little bit more about heat and how it travels, we are going to take that just a little bit further, and we're going to talk about conductors and insulators. And so these are the words that I'm saying. I'm saying conductor and an insulator. Now, let's start with conductors. Conductors are materials that encourage the energy to move easily. Generally, it's quickly or easily. So the energy will move easily. And then an insulator, of course, is just the opposite of that. An insulator, there are times where you don't want the energy to pass or to pass as quickly. Sometimes you want to even trap the energy in or block the energy out. And when you do that, you need an insulator. So insulators will often slow, stop, or trap the heat. I'll show you an example. Okay, so I have an extension cord, and for an extension cord to work well, you need both a conductor and you need an insulator. So as a conductor, you need a part that will allow the energy to flow. If you plug in a TV, you want instant energy. You don't want to plug in a TV and then in 3 days watch a movie. So you want it quickly, you want it easily. You need a conductor that will allow that energy, that heat, to pass through. Now the problem is, if you get it to pass through, you don't want it to pass to you. All right? So you need an insulator. As you can see, you have a metal end, which is your conductor, that will allow the energy to pass. If we opened up the wire on the inside, you would see even more wire going, or metal going all the way through, but it is coated in this kind of plastic material, and that plastic is a great insulator because it protects my hands and protects my body from the energy passing through me. So it makes it go just through the cord and not to me. So that's good, right? There are times when we talk about conductors and insulators and you need to use, some common sense. Think about the function of the object and not get so caught up in the exact material. So for example, my door is made of wood and metal and glass. So we have 3 different types of materials that the door is made out of. But, and some would argue that, oh, it's metal, so it must be a conductor, or oh, it's wood, it must be an insulator. But I want you to not get caught up on, what the door is made out of or how big the door is. I want you to think about the function of the door. So if I go outside and I still continue to talk to you, you'll notice something very strange. So what I wanted to say is that a conductor allows the energy to pass through easily, but an insulator keeps the energy from passing. What I said was a conductor allows the energy to pass through easily. Do you see the difference? So what does it do? It didn't totally block out my sound energy, and the same thing, the same rules will apply for heat. An insulator is meant to slow, trap, or stop the energy. And in this instance, you could probably still hear my voice just a little bit, but not quite as clear as when the door was completely open. And that is true for insulators. An insulator can trap in or trap out. In this instance, the energy was, blocked out. It was kept out in the hall. Of course, a little got through, but when you removed the insulator or opened the door, then more energy was allowed to pass through. So it doesn't really depend all the time what the material is made out of. Just think about the function. A window is the same way. The function of a window. It doesn't matter that it's clear. It doesn't matter that, you know, it might be made of glass or a certain type of material. What it matters is that it is used to stop or trap or slow down heat. If it is warm inside the classroom, the heat will exit if you open the window. If it is cool inside the classroom, the heat will enter if you open the window. So, doesn't matter the material, it matters the function. In just a second, I'm going to help test some objects for you so that you can see if the material that the object is made from, if it is a conductor or an insulator. We will test wood, glass, plastic, metal, rubber, and air. And air is going to be a really fun one. Okay, so I have some things from the lab that I am going to use to help test our materials to see if they are conductors or insulators. I have 3 alligator clip wires. I have a bulb that's in a holder, and I have a battery that's also in a holder. And what I'm going to do is I'm going to build a simple series circuit, but I'm going to be using 3 wires. Typically you only need 2, but we need a testing area. And if you're not exactly sure what that means, if you'll just hang on, and I will show you exactly what's going to happen. So, connect the bulb. This will be the testing area. So for now, these 2 have to make contact. And then I need to go ahead and connect the battery. There we go. Voila. The circuit is complete. The energy is passing from the battery through the wires and to the bulb. If we tested an object that was an insulator, it would look like this. You would have no energy from the light going to the light, and the light would not shine. Now what I'm going to do is I'm going to get the wood, glass, plastic, metal, rubber, and air, and we're going to test them to see if we can get the light to shine. If the light shines, it's a conductor. If the light does not shine, it's an insulator. Okay, now that I have my materials, we're going to test. The first material on the list is wood. So we are going to test to see if this wooden popsicle stick, if it is a conductor or an insulator. So let me connect to each end of the wood. And the bulb does not light up. So the energy is not able to pass enough through the wood to enable the light to light. So we would say that wood is an insulator. Now we will test glass. And this is a small streak plate that I use when I teach the rock lessons. And instead of kind of clipping the glass, I don't want to break it. So what I'm going to do is I'm just going to touch the glass on each side. If it is a conductor, it will allow the energy to pass through and light the bulb. So the energy did not pass through, and that means that glass, the material of glass, is an insulator. Next is plastic. So I have a little plastic disc. I don't even know what this is used for. I just have a bunch of these in my classroom someone gave me. So I'm going to connect on both sides. No light. So plastic is also an insulator. So far wood, glass, and plastic are 3 materials that are insulators. Now we're going to try this metal paper clip. So I'm going to connect on each side. There we go. We have light. So what does that mean? Well, that means that metal is a conductor. It allowed the energy to pass through the battery, through the light, and it just continues that circle of energy. We have a rubber band. We're going to test to see the material of rubber. Connect there. Connect there. No light. So rubber is an insulator. Now the last one is a little tricky because you can see that I have a styrofoam cup, but we didn't say that we were going to study cups or styrofoam. We want to know air. And the reason why I use a styrofoam cup for air is that styrofoam cups are actually 98% air. And I'm going to show you something really cool with that. So what I have is I have a glass container and I have acetone. And I'm going to pour just a little bit of acetone, don't get it on your clothes, into the container. Now to show you the reason why we are using a styrofoam cup to study air is I want you to watch what happens. As I put the cup in, you should see lots of bubbles. You may even be able to hear it. You see that? Now it's not melting because the liquid is not hot. It's not melting at all. All right, and I'll just show you. This is all that remains from a styrofoam cup. So this is all that is left from that styrofoam cup. It's almost like a very soft putty or a not very slimy slime. Do you see that? All of the air escaped, and this is all that we have left from that cup. So because the styrofoam cup is mostly air, we can get good results by studying the cup, since it would be hard to connect air, right? So I can clip here, and I can clip here, and we get no action in the bulb. The bulb doesn't light up at all. So yes, a styrofoam cup is an insulator, but because it's 98% air, we can also say that air is also an insulator.